Hi, today we're going to do volume of pyramids and cones. Remember, if I go too fast, feel free to pause the video. You want to draw the diagrams down. If you did not watch the demonstration video, I'd like you to pause this video and go back and watch that. Otherwise, when I start to derive the formulas, you're going to be really confused. All right, so let's derive the formula of a pyramid. Remember, derive is just a fancy word of saying we're going to take knowledge that we know, we're going to put it together, and we're going to create new knowledge. All right, so from the demonstration video, we learned that it takes 3 volumes of a pyramid to fill up the volume of a prism as long as the pyramid and the prism has the same base and height. Okay, so it takes 3 volumes of a pyramid to equal the volume of a prism. So let's write that out because we know that. 3 times the volume of a pyramid equals the volume of a prism. So from here, we're going to kind of deconstruct what we know. We know this piece here, volume of a prism. We know what that formula is. It's the area of the base times the height. Okay, so everything else stays the same in the formula. We're just going to change that piece. Now, I'm trying to find the volume of a pyramid, so I want to get this all alone. So my issue is that there's a 3 here, and I need to move it to the other side of the equation. It's multiplying, so the opposite would be to divide. So when I divide that, it moves on to the other side. So now my volume of a pyramid is 1/3 the area of the base times height. So that is the formula we're going to use, because when we took 1 volume of a pyramid and filled it up in the prism, it only fills up 1/3. Now, oh, you know what? I have to go back, sorry. This height here in the formula is true height. So I know in surface area we use the L, which is slant height, which means it doesn't create a 90-degree angle. Okay, so when we see the cursive L, we're talking about slant, no 90 degrees. When we see this is true height, which means it has to create a 90-degree angle with the base. Okay, so over here, we're going to go from the point all the way down to the base, and it's going to be 90 degrees. That's the height. Okay, so when we use an H, we're talking pyramids, that's what I'm talking about. That's the part we need to use. Okay, slant height isn't going to be used in the volume unless I need it to find the height. Otherwise, it's not going to be used in the formulas. All right, let's talk about a cone, and let's derive the formula of a cone. Okay, again, from the video, we know that with cones, just like with pyramids, it takes 3 volumes of a cone to equal the volume of a cylinder. And the cylinder and the cone have the same circle base, the same diameter. Okay, so again, we're going to deconstruct it. Take what we know. We know what the volume of a cylinder is. It's pi r squared times the height. Okay, everything else stays the same. Right? And again, I'm trying to get the volume of the cone, so I'm going to divide the 3 that I don't need. And now I have the formula. Volume of a cone is 1/3 pi r squared times the height, because we saw in the video that if I take 1 volume of a cone and fill it up in a cylinder, it only fills up 1/3 of it. Okay, and again, when I see this height here, we're talking about true height from the point all the way down to the base is the height. Also to note, it goes through the center of the circle as well, because it's going straight down the middle. Okay. All right, so let's try some example problems together. First one is a cone. So we need to find the volume of a cone. Okay, the formula for a cone is 1/3 pi r squared times the height. So I need the radius and I need the height. They give me the diameter. So I know that the radius is going to equal 5. All right, so I can fill that in. I already know that. All right, I need the height. I do not have the height. Okay, so I'm going to draw the height in. Remember, it goes from the point down through the center of the circle, 90 degrees. I need to find that. Okay. Oh, I think I accidentally erased something. This is supposed to have 13 centimeters. That's supposed to be given to you. Sorry. All right, so I have the height there. This 13 is actually the slant height because it goes on the diagonal. Okay, so I can't use that in my formula. It's not the true height. I need h here. Okay, but what I should notice now is that I created a right triangle. Okay. I have one side, the hypotenuse is 13. I have another h that I need to find. And this right here goes from the center to the edge of the circle, which is the radius, which I know is 5. Okay, so right triangle, I have two sides, I need to find a third. Pythagorean theorem is my best friend. All right. When I solve for h, I get 12. So my h here equals 12. Okay, so I'm going to put 12 here. And when I multiply that all together, when I multiply the 5 squared times the 12, I get 300. And then I have to divide by 3 or multiply by 1/3 if you want to use the fraction button in the calculator. When I do that, I get 100. And I just have to remember to put pi next to it, and my units is centimeters cubed. Okay, again, with e-learning, if you have the ability to write, we're going to leave pi in it because next year you're going to see things with pi that you can't multiply pi through because it represents angles. But if we are doing something where you have to type the answer, you can multiply pi through and give me a decimal. All right, let's try another example. We're going to find the volume of the regular pyramid. The first thing I want to take a look at, this is inches. The first thing I want to take a look at here is that it says a regular pyramid. Regular. If you remember far back to the first video of this unit, regular pyramid meant that all sides are equal. Okay, so anytime you use the word regular with a polyhedron, it means that all sides are congruent and all angles. We don't need to worry about the angles though. So all these sides, every edge is equal to each other. So if one edge is 4, all the other ones have to be 4. All right. Now my volume of a pyramid is 1/3 the area of the base times the height. So let's focus on the area of the base. So this is my base. Okay. I have, it's a rectangle, or actually it's a square. So it's still base times height, but because it's square, both of these are 4. So it's 4 times 4. Remember, this h represents the area of the base only, not the 3D solid. Okay, so that's 16. So I can put that in. All right. Now I have to find the height of my pyramid. I do not have that. So it's down all the way 90 degrees. I need to find that. Okay. What I would love to do, I'm going to draw it in, but we can't do it. What I would love to do is just take this way. I didn't draw this very well. It should be going through the center, and then going down the slant height and taking the slant and this to find the h. But the problem is I don't have the slant height either, so that's not going to work. Okay, but I'm still going to actually connect this way. What happens here is because this is 90 degrees, it actually does cut this in half. So now each piece here is 2. Okay, because it's going through the center of the pyramid, and because it's a regular pyramid, it cuts all the edges in half when I go to an edge. So this distance here is the same distance here, which again, if that's being cut in half, is 2. Okay, now what I'm going to do, I can't use that triangle, but I know that this here is 4. Okay, so if I can figure out this right triangle, if I can use that right triangle, I know it doesn't look like it, but it is a right triangle, I'll be able to find the height. The only thing I need for that right triangle is this. Well, right here is another right triangle, and I have 2 sides. They're both 2. I'm going to redraw this outside the shape. Okay, so I have a right triangle here with 2 and 2. The legs are congruent. That tells me that this is a special right triangle of 45, 45, 90. So to get to the hypotenuse, I multiply by square root of 2. So this right here is 2 square root 2. So now I have a right triangle here where the base is 2 square root 2 and the hypotenuse is 4. So I can use Pythagorean theorem to do height squared plus 2 square root 2 squared equals 4 squared. Now, I want you to notice that 2 square root 2, I put it in parentheses. When you put it in your calculator, you need to put it in parentheses. Otherwise, you are going to get the wrong answer. Okay. I get that the height squared is 8, so then I have to take the square root of 8, and I get 2 square root 2, which as a decimal is about 2.83. You can use a decimal because we're doing volume. All right, so this height right here is 2.83. 2.83. Now I can multiply that by 16 and divide by 3. And I get 15.08. 15.08 inches cubed. All right, this one's kind of a challenge problem because of this piece here. It's very different than what we've done in the past. All right, next I want to do a combo problem with you. Remember in the last video we learned that combo problems are really easy when I'm doing volume. All I have to do is take the volume of the first shape and add it to the volume of the second shape. So my first shape, so if I'm finding total volume, my first shape is a cone, and I'm going to add it to the volume of a cylinder. All right, so my volume of the cone is 1/3 pi r squared times the height. Okay, so I know it doesn't look like it, but this is the same circle for the cylinder and the cone. So if the cylinder's diameter is 12, this is also 12. So then the radius is 6 for the cone. And I need the height of the cone. I don't have it, but again, we're going to draw it in. Let me erase some of this stuff so it's a little neater. All right, so we know diameter here is 12. We're going to draw in the true height here, 90. Remember, it goes through the center, so it cuts the diameter half, making that 6. This is the height, and so now I have a right triangle here if I use the slant height here, and I can use Pythagorean theorem to find, oops, that 6 should be squared, to find the height. Okay, so the height is 8. All right, so then I multiply that together, and I divide by 3, and I get 96 pi. All right, and then I can find the volume of the cylinder. The volume of the cylinder is just the pi r squared times the height. The radius is still the same because they share the diameter, so it's 6. And then the height of the cylinder goes from here to here. Okay, so if the total height is 20, I know that this piece is 8. Here I just have to take 20 minus 8, which gives me 12. So the height of the cylinder is 12. So I multiply that together, and my answer is 432 pi. So then to find total volume, I add my two answers I got here together, and I get 528 pi meters cubed. Okay, so again, combo problems are super easy with volume. I just add together. If I had a hole, so if I had a shape, let's say I had a cylinder that had a cone hole in it, and that was a hole, I'd actually take the two volumes and subtract them, and that would be it. Okay, so volume with combo problems, whether it's two shapes together or it's a shape with a hole in it, is very simple.